We'll be writing an essay on the gastric motility, and then we add a note on the factors that affect gastric emptying. And this was asked in receipt of 2023. Here's my outline I will use to answer this question. An introduction, the functions of the stomach, then the different mechanisms through which gastric motility works, and then I will discuss the factors that affect gastric emptying. Now, what becomes of the introduction of gastric motility? The introduction will say that gastric motility is the movement of the bolus of food from the lower esophageal sphincter to the small intestine, from the lower esophageal sphincter to the small intestine. So how food moves from lower esophageal sphincter into the stomach and then to small intestine is what we consider as gastric motility. The next point should be the functions of the stomach. There are 4 functions. Function number 1 is that it serves as the storage site. Storage sites serves as a storage site for ingested food. So ingested food that we eat is sometimes stored inside the stomach, even as much as up to 3 or 4 or even 5 or 6 hours, depending on the food's constituents. Number 2, secretion of gastric juice. Secretion of gastric juice, and gastric juice is rich in some substances. Gastric juice, which is rich in substances like intrinsic factor, substances like pepsin, substances like HCl, acid. Now, what's the third function of our stomach? The third function is that it helps to break the bolus into chyme. It breaks it down into chyme. And then the fourth point, it regulates the release of chyme into the small intestine. It regulates the release of chyme into the small intestine. So those are the 4 functions again you must remember of the stomach. Storage site for ingested food, secretion of gastric juice, which constitutes substances such as intrinsic factor pepsin and HCl, breaking bolus into chyme and regulating the release of chyme into the small intestine. Now let's begin with the mechanism themselves. For the mechanism, I have the first one, which is receptive relaxation. Receptive relaxation. Now, for receptive relaxation, you must say that this occurs in the upper portion, in the upper part of the stomach. Now, since this occurs in the upper part of the stomach, it is a function of distensibility. The distensibility of the stomach. So the distensibility of the stomach, and as the stomach distends, this will increase the content that is emptied into it. And if it increases the content that it empties into it, you must add that this will not change intragastric pressure. Because this is an important point that you must not forget, intragastric pressure. So that is what you say again in the receptive relaxation occurring in the upper part of the stomach. It is a function of the distensibility that increases the amount of ingested food that enters into the stomach, but will not increase intragastric pressure. Now, for peristalsis, what are things to say here? Number one is that peristalsis occurs in the caudal region of the stomach. By caudal region, I mean the lower portion, the caudal region, or the lower portion of the stomach. What else again to talk about in peristalsis? I would say that peristalsis is a function of some kind of what we call the basic electrical rhythm. It works on the basis of what we say the basic electrical rhythm. What are basic electrical rhythm? Basic electrical rhythm are formed by alternate depolarization and repolarization, alternate depolarization and repolarization that form some kind of waves that runs in 3 to 5 rates per minute, which is also called the slow waves. The slow waves. Okay? So we have said peristalsis occurs at the lower portion of the stomach. Peristalsis on the basis of what we call basic electrical rhythm. And basic electrical rhythm are alternate depolarization and repolarization that occurs in 3 to 5 rates per minute and that are also called slow waves. Now, it is necessary you understand what happens here. What happens in peristalsis is that if I show you how the stomach looks like in this shape, like this, something interesting occurs. Now, first things first, this is the mid stomach, the middle of the stomach, the mid stomach. So food will increase its density and depth. So once there is a depth, it will first of all push it to the peristalsis and will send it back again. So this particular peristalsis does that circular form. Pushes it down to peristalsis, sends it back, pushes it down to the pylorus, sends it back, down to the pylorus and sends it back. So I say, from the mid stomach, down to the pylorus, and back again to the mid stomach. Now, this particular step that helps it is what we call retropulsion. Retropulsion is pushing it back to the mid stomach. And it is because of retropulsion that we have adequate mixture. Retropulsion helps for adequate mixture of chyme. Adequate mixture and breakdown of chyme. And breakdown of chyme. So we're able to appreciate that of receptive relaxation, that of peristalsis. Let's talk about hunger contraction. For hunger contraction, we say that hunger contraction occurs when there is peristalsis on an empty stomach. That's the first thing you must say. When peristalsis occurs on an empty stomach. Now, what becomes of the second point? For the second point, we should be able to appreciate that this is going to be maximal at the third day. It is maximal at the third day, and you must be able to note that after that, it declines or it stops. So the person stops experiencing hunger back. And then lastly, it is associated with pain sensation, associated with pain sensation. So I've been able to appreciate them again, that for the certain relaxation occurs in the upper part of the stomach, the sensibility increases, increasing the digested food content that can enter, but this does not increase intragastric pressure. For peristalsis occurs in the lower portion of the caudate. It works on the basic electrical rhythm, which we say is alternate depolarization and repolarization that runs in 3 to 5 rates per minute, which is also called slow waves. And we have said the movement is from the mid stomach to pylorus and back to the mid stomach. And I said moving from pylorus back to mid stomach is also called retropulsion. And retropulsion helps for the adequate mixture and breakdown of chyme. For hunger contractions, it is peristalsis that occurs on an empty stomach. Maximal by the third day and will eventually stop thereafter, and is associated with pain sensation. Now, for the factors that affect gastric emptying, I think I'll be quite straightforward with this, as there are lots of there are not much things to talk about them. For factors, number one, the volume. The volume of the content is directly proportional to the gastric emptying. This means that if the amount of food in the stomach increases, this will eventually increase gastric emptying. And alternatively, if the amount of food in the stomach decreases, this will eventually decrease gastric emptying. Endeavor to explain it on both sides. Now, for acidity, remember, acidity should be inversely related to gastric emptying. I think it should be directly proportional to gastric emptying. Let me explain what I'm saying. I'm saying that as we increase that should have been pH then, so over GE. Now, look at this. pH is directly proportional to GE. Now, what I mean is this. Now, watch. pH of a substance, if you want to express it as acidity, the pH should be a low pH. If you want to express it in alkalinity, it means it's a high pH. As you increase pH towards alkalinity, that will cause increase in gastric emptying because duodenal contents or the duodenum, which is the small intestine, is alkaline in nature, and that will be best for that medium. But when there is increase in acidity, pH has fallen. Increase in acidity means that food contents in the stomach will eventually need to meet the duodenum. Now, imagine a situation where we have our pylorus like this. Here is alkaline. Here is alkaline. Here is acidic. Now, if there is so much acid content here in the stomach, we will not want to release it into here because remember, we want to do a neutralization reaction in a very progressive manner. So whenever there is increase in acidity of stomach contents, the way we empty it will fall and vice versa. So acidity is inversely proportional to gastric emptying, or you can easily put it this way, that pH is directly proportional to gastric emptying. Now, food consistency. For food consistency, fluids are going to be more than semi-solids, and semi-solids are going to be more than solids themselves. What I mean is this. Fluids are easily emptied into the duodenum. Gastric emptying is faster in fluids than in semi-solid, and semi-solids are going to be faster than solids themselves. And in chemical composition, which is the last one, you are going to say that the chemical composition, that carbohydrates are emptied faster than their proteins or their lipid counterpart. And then you add the reason. The reason should be because carbohydrates happen to be the primary source for glucose, which is the primary source of energy. So we will absorb carbohydrate first so that it provides energy in the form of glucose before other chemical composition substances like that of proteins and lipids. All right. So with this, we call it up for this essay here. And I really do hope it made the most sense to you. See you next time.